No other planet captures the human imagination as Mars does. The reason is the striking similarity between Earth and Mars in many respects. Compared to the extremely hostile conditions on other planets, Mars, with its familiar surface features like hills, valleys, highlands and plains, polar ice caps, its relatively benign surface temperatures, and its day, which is a little longer than an Earth day, has made humans gaze at it with curiosity and excitement. For centuries, humans have observed Mars as a red dot in the night sky, moving slowly against a background of fixed stars. India's Mars Orbiter mission is an essential part of this global effort to understand Mars in more detail. The Mars Orbiter mission envisages sending an unmanned spacecraft to Mars and putting it into an orbit around the planet, conducting modest yet meaningful exploration of its surface, atmosphere, and the space environment in its vicinity through the spacecraft is the main scientific objective of the Mars Orbiter mission. The Mars Orbiter mission spacecraft is shaped like a cuboid and weighs 1,340 kgs at launch. Special alloys and composite materials have been used to build the skeletal structure of the spacecraft. Its inside temperature will be kept within safe operating limits using a host of materials, including a bright golden-colored multi-layer insulation blanket. The 3 solar panels projecting from one of its sides of the Mars Orbiter mission spacecraft generate about 800 watts of electric power near Mars. The 2.2-meter diameter dish-shaped antenna projecting from the other side of the spacecraft facilitates the spacecraft's radio communication with the Earth. In addition, it enables the accurate measurement of the distance between the spacecraft and the Earth. A variety of sun and star sensors, along with gyroscopes, enable the precise determination of the spacecraft orientation, which is very critical during different phases of the mission. The microprocessor-based control system of the spacecraft acts as its electronic brain and very accurately maintains or changes its orientation and orbit. For this, it relies on the spacecraft's reaction wheels and small rocket engines called thrusters, as well as the spacecraft's main rocket engine called the liquid apogee motor. To study the surface of planet Mars and its atmosphere, as well as the space environment near the planet, the Mars Orbiter mission spacecraft carries 5 scientific instruments which are usually referred to as payloads. They include cameras and spectrometers and together weigh about 15 kilograms. The Mars color camera of the spacecraft is designed to take color pictures of the surface of Mars and its 2 natural satellites, Phobos and Deimos. It helps in studying various Martian surface phenomena. The Thermal Infrared Imaging Spectrometer payload helps in the identification of Martian minerals. The methane sensor for Mars is intended for very accurately measuring methane in the Martian atmosphere and mapping its sources. Of the 2 other payloads, the Lyman Alpha Photometer helps in understanding the processes responsible for the loss of water from the Martian atmosphere. Finally, the Mars Exospheric Neutral Composition Analyzer MENCA payload will study the space environment around Mars. The precious scientific data gathered by the spacecraft's payloads will be transmitted to Earth through its 2.2-meter dish antenna. The incredibly weak radio signals whispered by the Mars Orbiter mission spacecraft will be received by the antennas of the Indian Deep Space Network at Bailalu near Bangalore. The mission to launch India's first Mars spacecraft happens to be the 25th launch of the versatile and well-proven PSLV and is designated as PSLV C-25. After its liftoff, it will take about 42 minutes for PSLV C-25 to place the Mars Orbiter mission spacecraft into an elliptical orbit around the Earth.
Mangalyan, India's first mission to Mars, left the Earth's orbit on December 1, 2013. When it reaches the Red Planet on September 24, it would have covered a distance of 780 million kilometers in 10 months. But here is an intriguing question. Mangalyan was launched from Sriharikota on November 5th and kept orbiting the Earth for 25 days before setting off for Mars. Why? After all, NASA's Maven mission, which took off 15 days after Mangalyan, went straight to Mars. This is how it worked. On November 5th, the PSLV put Mangalyan in a low elliptical orbit, with a minimum distance from the Earth of about 240 kilometers and a maximum distance of 24,000 kilometers. Technically, the minimum distance is called the perigee and the maximum the apogee. When the satellite is placed in orbit, it does not require additional fuel or energy. It keeps on moving, much like the Earth moves around the Sun. But at what speed does the satellite move? Well, this is determined by two things: distance from the Earth and the shape of the orbit. The closer the satellite is to Earth, the faster its speed, as the gravitational pull is higher. As far as the shape of the orbit is concerned, the more elliptical the orbit, the higher is the speed of the satellite. Now let's see how ISRO used two principles to increase the speed of the satellite. According to the first principle, when the satellite is at the perigee, its speed is at its highest. So if you give the satellite a little push when it is there, you can make it move a long distance. When the satellite is at its perigee, the mission controller in Bangalore often fire the motor on board to push the satellite into a higher, more elongated orbit, thus increasing the speed of the satellite significantly. Between November 5th and November 16th, ISRO made 5 orbit-raising maneuvers, increasing the apogee to 193,000 kilometers, which is 8 times the height at which the satellite was first placed. This pushed the speed of the satellite to nearly 11 kilometers per second, which is close to the escape velocity. So all that the mission controller needed to do on December 1st was to burn the motor one more time and push the satellite out of the Earth's sphere of gravity into the Sun's gravitational influence. Since the Earth is orbiting around the Sun at a speed of 1 lakh kilometers per hour, Mangalyan exited the Earth's sphere of influence with the same speed.
During its 300-day journey to Mars, the spacecraft will leave Earth's sphere of influence when it will move beyond 1 million kilometers from Earth. Then, it will travel in a curved path, mostly under the influence of the Sun. Finally, when the spacecraft is about 500,000 kilometers from Mars, it will come under the sphere of influence of Mars. As the spacecraft nears Mars after its 10-month-long journey, lasting millions of kilometers from Earth, its LAM will be fired again. This time, it will be to sufficiently slow down the spacecraft to enable it to be captured by Mars in an orbit around it.
The satellite will then fire its onboard motor, but this time in reverse direction to slow down its speed, so that Mars can take Mangalyan into its own gravitational sphere of influence. Mangalyan will then start orbiting Mars for about a year. So, if anybody ever asks you, why is it that traveling to Mars takes only as much fuel as traveling to the Moon does, even though Mars is about 100 times more distant than the Moon, you know the answer. Most of the fuel we need is just to launch the satellite. The rest of the journey is mostly courtesy of gravity. If only we could travel with such ease down here on Earth.